Hi there, I'm Nix, and the topic for today's video is the check if n and its double exist problem on the LeetCode website. As always, I'm going to solve this problem in the C++ language and give you a detailed explanation of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of the time complexity and space complexity of said algorithm, as well as looking at the LeetCode rankings. If that sounds good to you, then stay tuned. Welcome back. Now, in this video, I'm going to go over two different solutions to this problem, with kind of a bonus tweak to the second solution thrown in, and seeing how that change affects the solution. Now, with that mysterious foreshadowing completed, let's get straight into it. Given an array, named after a pirate sound again, of integers, check if there exist two integers, n and m, such that n is the double of m. Alright, more formally, check if there exist two indices. The two indices are different from each other. They are both valid in the array length, and that one of the values is double the other. Okay, and then we have several examples here. So, for example, in this one, this output is going to be true because the array has both 10 and 5 present in it. Much like this one has 7 and it's double, 14 present. But this one doesn't have anything that is a double of another value present, so it's false. Alright, constraints. We are never going to be given an array that's less than 2 or greater than 500. And the values range from somewhat negative to somewhat positive and everything in between. Next up is the planning of the solution. Now, the first thing that popped into my mind was the intuitive brute force way to go about solving this problem. The way to do that is, if you start at the beginning of the array and say, hey, what's that value? Oh, it's 10. Well, in order to figure out whether its double exists, I'm going to have to iterate again through the array at the position that's one higher and go through the rest of the array and ask myself the question of, is that value that I'm looking at double or half that? Because at the current position that I'm in, I don't know if I'm looking at n or I'm looking at m at this point. So I start my iteration, I'm at 10, and now I'm going on to the second iteration, and for everything that I see, I have to ask, well, is it 20 or is it 5? Well, that's 2, so that's not gonna be what I want. So, moving on, I look at 5. Hey, that's 5, that's half that of 10, so that is true. So basically, this means that solving this problem with that brute force method requires little more than nested loops. So let's get to the coding phase. Okay, here's the first for loop. Now this is the first iteration, and it's going to start at the beginning of the array and go all the way to the array size -1. Now here is the second for loop. This is going to start at whatever the I index is +1 and go until the absolute end of the array. So if we're at 6, it's going to start at 22 and go all the way to the end. And the reason this is array size -1 and this is array size has to do with what happens at the very end of the loop combinations. So when I is equal to the last value, j is already going to have that final value covered, being set to I +1. So this never needs to go to the end of the array. If it does, j would be considered out of bounds. Okay, now we get to the if branch that handles the comparisons. So if the value at the I index is equal to twice the value of the j index, or, this is the or operator, the value at the j index equals 2 times the value at the I index. So we're looking if it's double or half the value that we're currently on the position of. Then if that condition is true, we're going to return true. The last thing to add is if we've gotten through the entire nested for loops and we still haven't found anything that fulfills the condition, then we're just going to return false, and making sure that this return value exists outside of these for loops. So with that, this code should be able to handle everything that's thrown at it. So let's see if it works. True, true. Very nice. Let's go for the full shebang. Pending, judging, and accepted. Woohoo! Alright, now for some time and space complexity to look at. The nested for loop nature indicates that the time complexity is going to be on the order of big O of n squared, because this for loop depends on the array size, and this for loop depends on the array size. So time complexity being big O of n squared is not the best. Now, in terms of space complexity, however, with these just being for loops, an if statement, which is constant, I didn't have to make any additional containers, so this would have a big O of 1 space complexity. Very good in terms of space complexity, but not the best in terms of time complexity. So let's see where this falls in terms of rankings. Okay. That's interesting. Beats 94.2%. Take that with a heavy grain of salt. 107 test cases. And memory usage is here. It beats 50%. And looks like there's two different distributions here, which kind of clues you in that there are two different solutions that can be done. And speaking of which, let's go ahead and see those solutions. This was the brute force method for doing things. Now let's look at a second solution for this, with the goal of trying to reduce some time complexity, get something that has a solution that isn't big O of n squared. To be able to do that, we're going to take advantage of a different container's properties. So I'm not going to make a new array, I'm not going to make a new vector, I'm going to make a map. What's a map? A map is a container that stores key value pairs. Now think of it in terms of a dictionary. A dictionary contains a bunch of words and their definitions, much like a map will contain a bunch of keys and their values. Word is equivalent to a key, the definition is equivalent to its value. Now the map that is present in the standard template library for C++ has a find function. Now that find function is going to be useful for reducing the time complexity of our answer. We'll get more of it into that once we do the analysis. But that's our goal, to use the find function in a map to reduce our time complexity. So what are we going to need for this solution? Well, we're going to have to make a map, and we're going to have to fill that map with key value pairs. Now in this case, my key is going to be any unique value that is present in the array. My value is going to be how many times those numbers show up. So make a map, fill the map with all of the unique values and how often they show up in the array, and then use the find function on said map to figure out whether the double exists in this original array. Now those are the major points for this algorithm. But in using this map, we're going to have to pay special attention to a snag that could come up. This constraint here indicates that we could face a potential problem. Now remember, we're trying to create that map with all unique values and their count. And for the vast majority of these numbers within this range, from -1,000 to 1,000, if you double the number, you're going to get a different but still unique value, except for one value that's present in this range. 0. 0 could mess stuff up for us. Let's look at this example here, as well as this example here. In this array, and let's make this array 16, such that this is going to report false. This should, because no value present here is going to have its double present. This one here, however, we have a 0 present at one index, and at a different index, we have another 0. And 0, with its unique property of being exactly the same value if it's multiplied by anything, that different 0 at another index is going to fill the requirements of the condition we're looking for. We have a value 0 at one index I, and we have its double present, because 2 times 0 is 0, present at a different index. So this fulfills the condition. But if we just have one 0 present, well, the condition isn't fulfilled. We need to have two different zeros at two different indexes in order for it to be fulfilled. But in a map, it's just going to see that 0 is present. So if all we do is ask, hey, is this value that's double the initial value, is that present here? In other words, if we're asking, is double that value, 0, present in the array? Well, of course it is. Even if we just have one 0, if we double it and ask if that value is present in the array, it's always going to say yes, because even if we only have one 0, it's the same value when it's doubled. And that could pose a problem for us. But with a key value pair of keeping track of the count, 1, 0 versus 2, we have a way around that, because we can ask the map first if we are dealing with more than one 0. If we are, it'll fulfill the condition. If we aren't, it won't, and we have to find a way to kind of skip over that 0 and ignore it in all the rest of the cases. So with that, let's get on to the coding. Our first step was to make a map, and this is how to do it in C++. This is the variable type. I'm going to make a map with the key variable being an integer and the value variable being an integer, and I'm going to call that map value count. This for loop is going to handle filling the map with our key value pairs. So we're going to go from the beginning of the array index to the end of the array index, and we're going to fill the map with the key value pairs with this line here. This line means that the key that we're looking at is the value in the array at the particular index we're at, and the value is this here, the map value at that key. And the ++ here indicates that every time you see this particular key, you're going to increment the value by 1. So it's going to look at 6, add it to the map, and record that it's seen that 6 once. So its key is 6. The value pair that goes along with that key is 1 because it's seen once. Now, if this 22 was another 6, this line would say, hey, I've seen that key present here. I know that value is currently at 1 because I've seen it once. So I'm going to bump it up another, and I've seen it twice now. So this is what that line does. Next up is handling the scenario where we have multiple zeros present in an array. And we know that if we have multiple zeros that are present at different indexes, the count in the map is going to be more than 1. And if it's more than 1 and we have zeros at different indexes, that fulfills the condition and we should return true. So if the value count at the key being 0 is greater than 1, we should return true. Next up is this second for loop. This is what's going to handle every other scenario. And the first thing we need to do is handle the situation where we see a 0. So we're going to go through the array again, index equal to 0, going until the end of the array. And we're going to ask ourselves, if that value at that index is equal to 0, well, we're just going to increment I up. We're going to skip over it. And that will be okay to do in this for loop because this for loop is going to handle the situation where there's only going to be one 0 present. Because if there's more than one 0, this if statement that's above the for loop is going to catch that. Now, if this if statement isn't true, if we aren't dealing with the 0, we're going to go into this else branch. And this else branch is going to have a second branch statement present in it. And this is going to be what's going to handle the searching. This condition here essentially means that if you have found double the current value, return true. So you're going to look at the map. You're going to try to find this value, double the current array value at the index that we're looking at. And if you found it, that means you're going to be at a position that is not equal to the end of that map. So in other words, it's present somewhere in the map, which means it's present somewhere in the array. And if that condition is true, then we're going to return true. Now, if we've gotten past this entire for loop and we haven't found anything that has fulfilled this condition, then we're going to simply return false because the array doesn't contain n and it's double. Looking at this code here, this for loop is unchanged from the previous solution. We're still iterating through the size of the array, but this if statement condition has replaced that second for loop iteration using the find function. And the find function does not have a linear dependency on the input size. Essentially, what we're doing is using the find function of a map to replace that second nested for loop. Okay, let's see if this code works. Run code. Pending. Judging. True. True. Good. Let's see if I get green text. Yes! Green text! Green is awesome. Okay, now let's look at this code's time and space complexity. Well, the space complexity is not going to be as good as in the previous solution. We're creating a new container and we have to carve out some space in memory in order to create that. And we're going to fill it with all of the unique values of n that are present in the array. So it's going to depend on the input size. So it's going to be akin to big O of n. Now let's figure out the time complexity for this code. Well, we have a for loop here. That would be big O of n time complexity, linear time. We have if statements here doing constant work. And now we have this second for loop here. Now, you might be tempted to say, oh, one for loop, big O of n again, right? No. Within this for loop has this find function present. And much like if we had another nested loop present in it, those time complexities are multiplied together. We're going to have to multiply this for loop's time complexity by the time complexity of this find function. And for a map, the map's find function is log of n. A map in C++ is implemented by way of a balanced tree, so think like a red-black tree. Because of that implementation, the search functionality of this container is going to be dictated by log of n. Every time you're looking to see if a particular value is what you're looking for, when you make a decision, you can eliminate half of the content of that container every single time. Whenever you can do that, it's going to be dictated by a log of n time complexity. So this is going to be big O of n times log n, since the find function is nested within this for loop. And we also, again, we had this additional for loop present here, but remember in big O, we always take only the highest order term. We eliminate lower order terms, we eliminate constants. So, final answer, time complexity is n log n for this code. Now let's check the details here. Okay, runtime is down here. Again, take this with a grain of salt. Looks like LeetCode has condensed all of the solutions into a range here. And the memory doesn't register, which makes sense considering the higher memory capacity. But technically, in terms of time complexity, this is an improved solution to the previous brute force one, and yet it's down here in runtime. But again, we've seen in a previous episode that you submit the same code and you can ping pong between the various rankings, so take this with a grain of salt. Now, this code has an improved time complexity compared to the previous solution. We went from big O of n squared time complexity to big O of n log n time complexity. Now, believe it or not, you can make one single change to this code and get an even better time complexity out of it. You can go from n log n to just n time complexity. Now, what change would that be? Ta-da! Instead of making a map, you make an unordered map, utilizing a different container, and no other changes to this suddenly makes the time complexity go from n log n to n. And the reason for that is, much like a map, an unordered map has a find function. But this find function in an unordered map is constant time and averaged out. Only in the worst case scenario do you get it to be linear time. But in this particular situation, you're never going to get the worst case scenario happening, which usually means you're dealing with collisions present. So this find function for this code is going to be working in constant time. And the reason why this find function has a different time complexity for an unordered map than for a map is due to the differences in how these containers are implemented. Remember when I said the map was implemented by using a balanced tree? Well, an unordered map is implemented by using a hash table. And what that essentially means is that its search functionality is constant. So with technically 3 solutions, we have the nested loops that have a big O of n squared time complexity, but a big O of 1 space complexity. And then we have the map and unordered map solutions, with the map having a time complexity of n log n, and this unordered map having a time complexity of big O of n. Both the maps have a space complexity akin to big O of n, since you need to carve out some memory with them. Now, if I was asked on a technical interview a question of which of these solutions would be the better one, well, I would say it depends on what you want to optimize. If you want to optimize your memory usage as much as possible, and you don't really care how long it takes, then I would say the nested loop solution is your best bet. It's the quote-unquote better one in that situation. However, if you want to sacrifice some memory usage and want to get an algorithm that is as fast as possible, then I would say the unordered map solution is better because it has linear time, but in order to get that, you have to sacrifice some additional space in order to create the container. With that, let's prove that this unordered map change does indeed still work. See, true, true, submit, pending, judging, accepted. See, that one little change, you don't change anything else, still works. And let's see where we are in the rankings now. Again, we've been pinged up here, okay. And, okay, so it actually registers my memory usage. And predictably, we are down here instead of up here. The for loop answer had the you are here sign being within this distribution, whereas the added memory usage required to create that map plunks us down here. And with that, we have gone through a few solutions to the check if n and its double exist problem. I hope you got something out of this video, and as always, I will wish you a happy coding and have a nice day.